Hi, my name is Kyle Weaver, and I'm going to walk you through a few queries in Microsoft SQL Server Management Studio as part of Tutorial 2 for SSCI 582, Spatial Databases with Professor Swift. We'll open up the SQL Server Management Studio in our Windows virtual machine, and after the splash screen, we'll see an initial login and a connection screen. This screen allows us to select which SQL Server or other database system we'd like to connect to for this session. For ours, we're going to select Database Engine. A few other options are here. The server name keeps track of all the servers from previous sessions. In this case, we're going to use the GIS database server at USC, which is gis-db.usc.edu. We're going to keep that. And Windows authentication, since we're working on the USC GIS server, the Windows authentication will work just fine. So we'll hit connect. Once we're connected, we can create a database to work with, or in this case, we've already created databases as part of Tutorial 2. My database name is KC Weaver T2, and that's down here in the K's. And if we open that up, we'll see what we've done. In my folder, you'll see several subfolders which are used for various purposes in the SQL Server Management Studio. In this tutorial, we've explicitly created content in the database diagrams and in the tables folders. The system uses other folders for its own purposes as well. We haven't used them as part of Tutorial 2. In the tables folder, we see 5 user tables with the names City, Country, Great Lake, Lake, and Shore. We'll look at a few of these in a few minutes, but first let's take a look at our database diagrams. Database diagrams give us an opportunity to get a visual representation of the relationships in our table. We'll look at the with Shore database diagram. Lots of information in a relationships diagram. Here we see the 4 main tables. Great Lake is not one of the tables that we're using. We imported that for part of the tutorial. But the 4 main tables, Country, Lake, Shore, and City, are the tables we'll be working with for most of this tutorial. The lines connecting the tables indicate the key structure and show the type of relationship. So in this case, it's a many-to-one relationship with the primary key in the country. To find out the details, you can hover over this, and it says relationship foreign key shore country between country table and shore table. If you want to find out more information about this, over in the properties, you can see it there. In the tables and columns specification is where you can see the details of what fields are mapped to other fields. In this case, the base table is a shore using field in country. That's this one right here, and is mapped over to the country table with the primary key of name. Okay, if you need to edit these, you can also do that in this properties pane. Click on the 3 dots, and here's what the relationship actually looks like. And you select any of the numbers here. So we'll select country and name as our primary key, and then we'll just leave the shore and in country the same over there. Okay, we won't make any changes, but you would hit OK to do that. So shore and country, country name still remains the same. Well, you'll also notice here that shore has a second key going here, and if we hover over that, we'll see foreign key, relationship foreign key shore lake, between lake and shore, and that one is using the shore on lake field, this one here, and it maps to the primary table of lake with the field name as the name there. So that uses that one right there. If you haven't saved, just like any Microsoft product, it's best to save early and often, just like voting. So Control S to save this tab we're in, or Control Shift S if you want to save all. In the Object Explorer, find the lake table, which is right here. The first thing we'll do is just look at the design of it. So right-click, select Design, and in this case, the column names are in the rows, curiously. And we see what data type and the allow nulls. So in this case, each field has a name. It is of this particular type, and then the allow nulls checkbox is whether or not the field contain a null. If this is checked, that means the field can be empty or can be null. We'll go back over to Lake and do Edit Top 200 Rows, and that'll just open up a new tab and show us the data that's actually in the table. Okay, so 27 records, you can see that down at the bottom, with the names, which were the columns here, are the same as what we saw in the rows in the design table. So name, elevation, feet, depth, area, square miles, in country, continent, and this is well-known text in the actual shape information. So this is text that we imported as part of the tutorial from the Great Lakes database, or the Great Lake database, and then the shape will spatial data Microsoft SQL Server will use. So that's the lake table. We'll take a quick look over at the shore table. We'll do the same thing, look at the design of it. In this case, we have 3 fields with similar structure across the top. In this case, as we saw in the database diagram, the lake had 2 keys going to it. So it has in country, which links over to the country table, on lake, which links into the lake table. Because both of those are referentially enforced, they do not allow nulls. Shoreline, however, does allow a null, which means that it can have empty space. It doesn't have to have an entry in there. And to look at the actual data, we'll see what that looks like. So edit top 200 rows, and that'll show you the data in here. In this case, the shorelines are all filled in, and this is the information that we typed in. You'll notice that there are several entries of the same name. And these are the ones that are shared in US and Canada. That's the many part of the many to one relationship. Now let's look at some queries. Tutorial 19b asks, what are the names in alphabetical order of the Great Lakes that have shorelines in both Canada and the United States? In this case, we can do a pretty simple function where we do an intersect between the 2 tables, so it's a self-intersect. So we're looking both at the shore table and looking for the on lake, so the lake name. The first part is where it's in the United States, the second part is where it's in Canada, and then we'll just order by on lake. If we execute this query, we get, as expected, the 4 that had both US and Canadian shorelines. So we'll do a new query here. This is part 19C of our tutorial. And it builds on the previous query in concept, but the implementation is a little bit different. The question is, what are the names and length of shorelines in descending shoreline of the U.S., of the Great Lakes that have shorelines in both the Canada and the United States? Okay, so here we could see that the query we got for this one basically devolves what the intersection does automatically in SQL Server, but we use an inner join. Technically, this is a self-join since we're using the same table. So let's deconstruct this a little bit. The select statement is pretty simple. So we're selecting all the distinct names where the on-lake, the shoreline in the U.S., and the shoreline in Canada, with some simple, easy-to-read titles for the columns. This next section, the from in the inner join, separate the 2 instances of the same table. The first one we'll name as US, the second instance we'll name as Canada, and we'll do an inner join on those where the US name and the Canada name are both the same. Okay, and we'll also look at, from the US instance of the same table, where the in-country is United States, so where the shoreline's in the United States, and the other part where the in-country shoreline is in Canada. And then as part of the description, we said we would order by the descending length of the U.S. shoreline. So do a quick execute on this query, and as expected, the same 4 lakes that we saw in the last query, this time ordered by the longest length U.S. shoreline, and that's Lake Superior with a whopping 1,000 miles of U.S. shoreline. And for our last trick, we'll use the Spatial Results capability of the MS SQL Server to show that well-known text that we saw about in the lakes earlier. We'll select the shape and name from the lake. Select shape and name from lake where continent equals North America. Close that out. And when we execute that, what we get is a really easy to read table here. Oh wait, even better, we have the Spatial Results capability. So if you click on that Spatial Results capability tab, what you get is those well-known text, gives that outline for each of these polygons. SQL Server has the ability to display that. If we'd like the labels on that, since we included name in the select statement, we can select name column, and it will label all of the lakes. Lake Nipigon is not labeled just because of scale, so if you zoom in a little bit, then that will show up. All right, that's all we got. Thanks for watching. I hope you enjoyed the video.